Kia ora 9 WEKA. This is the last video I need to do on the JAF stats practice. This is part 4 and it's going to cover question 13 and then the extended abstract ones. So make sure you've got pen and paper. There's quite a lot of puzzle solving in these ones. I hope you enjoy them. I did. So the first one is not one of those. It's where we just have to find the average from a frequency table. So we're given here information about the number of goals scored in a season by a forward, and we have to find the average number of goals scored per game. So here, these are the options for how many goals the player scored, 0, 1, 2, 3, or 4, and the frequency gives us the number of games. Now, sometimes we write this thing here, oops, that's not the right pen that I wanted. We write this as the XIs. We call these the X's, and we call these the FIs. You don't need to think about it like that in Year 9, but it can help us. So what we're doing in the third column, where we've conveniently got a gap, is we're saying, well, let's see how many goals altogether were scored here. So there were 7 games where there were no goals. So that meant that there were 7 times 0 equals 0. There were 8 games in which 1 goal was scored, so that was 8. There were 5 games in which 2 goals were scored. So 5 twos gives me 10 goals. There were 2 games with 3 goals scored, so altogether, 3 times 2, we had 6. And there was 1 game where the forward scored 4 goals. Right, so that's why we multiply those numbers together, because we're trying to work out over the season what was the total number of goals. So we're going to add those up, and we'll get 0 plus 8 is 8, plus 10 is 18, plus another 10 is 28. So the total number of goals was 28. How many games were played? Well, that's what the frequency column is all about. So we've got 15, 20, and 23. So the mean is equal to the 28 goals divided by the 23 games. And if you work that out on your calculator, which is what I just hopped over to another screen to do, you get 1.2173, blah, blah, blah. So usually we're going to round that to 1 decimal place, or maybe 3 significant figures. So here I would probably say the mean number of goals is 1.22 goals. That's to 3SF. Or I think it would be okay also to say just 1.2 goals. All right, so that's how we find the mean from frequency data. We multiply these together, and that gives us, and then we add those numbers up, and that gives us our total here. But it's just really important that you understand why we're doing the multiplying together, as well as mechanically doing it. Okay, on to the next questions. So I put all these together on one page, even though they're going to take a little bit more room to work out. And they are a bit of a step up. You have to be really thinking about what the mean is and where it comes from. So question 14 goes like this. The total mass of 5 rugby players is 425 kilograms, and the mean mass of 10 ballet dancers is 40 kilograms. So what is the mean mass of all 15 people? So let's think about that. So the mean is equal to the total divided by how many people we've got. So in the end, we're going to be figuring out the mean for all 15 people. So we're going to have something divided by 15. What we need to do is to get the total weight for all 15 people. And that's not too hard, because we know the total mass of the rugby players is 425 kilograms, and we know the average for the 10 ballet dancers is 40. So we've got 425 for the rugby players, and we've got 40 times 10 for the ballet dancers. And we're going to divide that by 15. Okay, so that gives us 825 divided by 15. And if you throw that into your calculator, you'll get a lovely exact round number of 55 kilograms. Okay, so let's go over that again. What we did with this question is we were given information about one group where we had the total and the other group where we had the mean. So we want to be able to work backwards from the mean to the total and vice versa. Okay, so often in harder problems about the mean, we want to start by thinking about this equation and thinking about what do I know and what do I not know. So in the end here, we had to figure out the total, but we knew how many. The how many was 15, and this is what we had to get. Okay, on to number 15, which is a similar kind of problem. The mean mass of 5 giant dates was 50 grams. Kate ate 1, and the mean mass of the 4 remaining dates was 40 grams. What was the mass of the date that she ate? Okay, so if you haven't done this already, I want you to pause the video and try and figure that out now, just while I'm cleaning up the screen. So pause it and give it a go. I'll just get rid of this, give myself a bit more space. So it comes down to the same idea that we just used. The mean is equal to the total divided by how many. So in the first question, in the first part of the question, we're told that the mean mass of 5 giant dates was 50 grams. So for 5 dates, what was my total? Well, it was 5 times 50 grams. So the 5 dates altogether weighed 250 grams. Now, after she ate one of them, the mean mass of the remaining 4 was 40 grams. So we can say with 4 dates, the total is 4 times 40, and that's 160. Therefore, the 5th date weighed 90 grams. So 250 take away 160 is equal to 90 grams. Okay, question 16, starting to get more fun. Find 4 numbers that have got a mean of 7, a median of 8, and a mode of 9. So this is an example of a question that gives you lots of information. You just have to figure out where it's kind of hiding and how we can think about it. So there are different ways to do this, but I'm going to show you how I did it. Just let me get rid of that instead of going to a new page. All right, so we've got 4 numbers and we're given the 4 measures of the centre. So the way I started with this is that I just wrote down 4 blanks. Now, I know that the mean is 7, so the numbers have to add up to 28. So that's going to help. The total must be 28. The median is 8, but the mode is 9. So that means that I have to have 2 numbers in here or more that are 9, right? Because it wouldn't be the mode if there was only one 9. So let's put in a 9 here, and let's put in a 9 here. Now, if we make this number 8, what's my median? Well, it's going to be 8.5. So to get the median being 8, we can't have that one being 8. These two have to average to be 8. So this number must be 7. Okay? Let's have a look. We've got a mode of 9. We've got a median of 8. Now we just have to figure out how I will have a mean of 7. And that's easy because I started out by saying, hey, the total's got to be 28. So these add up already to 25. 9 plus 9 plus 7 is 25. So this first number has to be 3. Now let's go back, and when you get a question like this, it's like in Mathswell or OPS, you can always check your answer. So we've got 3 plus 7 plus 9 plus 9 gives me 28. So the mean is 7, the median's 8, and the mode is 9. Now you might want to just play around and check for yourself that there's no other combination that's going to work there. But you should see pretty quickly that with those 3 constraints, it's not possible to have any other 4 numbers that are going to work. If we had, let's suppose we tried having 3 number 9s, well then we don't have a median of 8, right? So that number can't be 9. What about if we made those 2 9 and this one 10? Well, that's definitely not going to work because, again, we don't have that median of 8. right? Plus the numbers are going to start to add up to more than 28. That would have to be 0. So that's wrong. So the only combination that's going to work is 3, 7, 9, 9. All right, now this last question 17 is pretty cool. Some of you might not be surprised that I'm going to use some algebra to do this one. I know some of you watching this will have seen different cool ways to do it, and if you want to leave comments, that would be really good. But this is how I thought about it. I've got 2 gold rods, and one of them is 70 centimetres long, and the other one is 20 centimetres long. Is it possible to break one of those into 2 pieces so that the length of one of the resulting 3 pieces is exactly the average of the lengths of the other 2 pieces? And if so, figure out what their lengths are. Okay, so here's how I started. I thought, well, I've got this one here is 70, and this one here is 20. So I need to break one of them up. Now, I could start by trying to break up the one that's 20, but probably this question might work better if I try breaking up the one that's 70 first. And that turned out to work really well. So if I break this up, I'm going to say let the new part be, or the broken up part be x long. So we're going to split it here, and we're going to make that part x, right? And then what's left over has to be 70 take away x. And this one here is still 20. So now I can do some pretty straightforward algebra to figure out how to solve the problem. So what are we looking for? Is it possible so that the length of one of the resulting 3 pieces is exactly the average of the lengths of the other 2 pieces? So let's look at this one and this one and see what we can say for the average of those. Well, we get 20 plus x divided by 2. That's my average there. And we want that average to be the same as the length of the other rod, right? That's what it says. Is it possible to break them so that the length of one is exactly the average of the lengths of the other 2? So the equation we're going to solve is this. So this is one of the reasons why I love algebra, is because it lets you solve problems that look like they're really, really hard. All we've got here is the stuff you learned how to do earlier in Year 9. We're going to solve an equation with x on both sides. By doing this, 20 plus x is equal to 2 times 70 minus x. Now this might not work. We might have to play around with different combos, but it might. So we've got 140 minus 2x. So collecting up x's on this side, I get 3x is equal to 120. And that tells me that x is equal to 40. Well, that's pretty cool. Let's see if it works. This is 40. This must be 30. And this is 20. So now, if we take the 40 piece and the 20 piece, and we take their average, we get 30, which is equal to the length of the third rod in here. So there you go. I've got one question left to do. I don't think I'm going to be able to squeeze it into a 15-minute video, so there will be a part 5 for these. Thanks for your patience. Let me know if you've got any cool ways to do those last couple of problems that are different from how I did it. Either send me an email or leave a comment in the YouTube comments.